suppose m varies directly as the cube of t. So we have to remember direct, and we have to remember inverse. And we have two different types of equations here. So the direct is y is equal to kx. The inverse is y is equal to k over x. And you can write those multiple different ways, but in this case, m is going to act as our y, and t is going to act as our x. But there's going to be something a little bit more tied to the t. So I'm going to write it as m, and the one is m of t, is equal to, the k stands for the constant, which never changes, right? It'll always be k. And then instead of actually having x there, I'm going to have t, but then it says the cubed of t. So I'm going to have t cubed, so to t to the third power. So m of t is equal to k times t to the third power. Now the next one says if the function varies inversely. So that's, I'm just going to rewrite it as m of t is going to be equal to k goes on top, and then that t to the third goes on the bottom, just like that. Moving on to number 9. We have to take a look at the graph. Now there's multiple ways of doing this, right? We can start to plot points, but what I'm going to do is I'm going to take a look at the transformations that are happening here and then create my own graph from this. So I can see right here this -1 and this +1, which means that I normally would have an order pair 0, 0. It means I'm moving into the right one and an up one. So there's going to be kind of the changing point between the absolute value function. Okay, this 2 here means that it's going to be a horizontal shrink, right? Because instead of multiplying by 2, I'm actually dividing by 2 to the x values. Okay, and then this negative right here, which means that it's going to be flipped over the x-axis. So it means that it's actually going down. So if it's shrunk horizontally, this would normally be 2, but since it's going to be a multiple of 2, right, that means I'm actually cutting it in half, so it's actually going to be in this location between 1 and 2, and between 0 and 1. And then we just keep plotting points from there. And when we draw our lines, it's going to look just like this. Okay, it doesn't need to be perfect, just as long as you're relatively close. Now we're going to take a look at whether it's increasing, decreasing, and other locations. Now, when we're talking about increasing, when we're talking about the interval, we're talking about the interval for x where the y value is increasing. So I'll say that again. So for increasing, we're trying to figure out what is the x interval in which y is increasing. So, and we always look at a graph from left to right, just the same way that we read. So if I'm following the graph all the way down here, and it keeps going up, 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 until it gets to that point right there. And then it goes down, 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 down. So it increases all the way from -infinity, so that's where it starts, all the way till it gets to the x value of 1. Now, depending on the specific type of book, they might actually include 1, but with calculus, we don't actually include 1 because it's neither increasing or decreasing at that point. And decreasing, we start at 1, and then that goes to infinity. Bounded, it's bounded above because the y values do not go off to infinity. They only go to -infinity, so it's bounded above. Odd, even, or neither. So, even means that it reflects over the y-axis. Does it reflect? No, because if it was actually 1 unit to the left, then it would reflect. But since it doesn't, it's not there, it's not even. Odd. Is it a rotation around the origin of 180 degrees? No, not that. So it's not even or not odd. So it's going to be neither. And extremes, which is going to be the highest point. Now, depending on the type of teacher, they might ask for the y value. I'm going to ask for the ordered pair. That is the highest y value. So I'm going to write down 1, 1. And you might want to also write down it as a max, and it's also an absolute max rather than a relative max. Okay, how is f of x related to the basic absolute value function? So the original absolute value function is absolute value of x. So I talked about multiple things, that it is moved up 1 unit, up 1, and it moved to the right 1. Then I talked about how there's a horizontal shrink, and that is going to be because it's being multiplied by 1/2. Or I could think about it as dividing by 2. Remember, whatever's inside that parentheses, or the absolute value, or the cube root, or the square root section, it's always the opposite, right? If you think about it as if it's minus 1, it's going to actually be 1 unit to the right, which you would normally think it'd be to the left. And this 2 right here, which you would think it would be multiplying by 2, the x value, but it's actually the opposite. It's dividing by 2, or multiplying by 1/2. And then the negative out in front is a reflect over the x-axis. Now you want to do the reflection first, and then move the figure accordingly. Moving on to number 10. Alright, so let's finish up the last page. Let's take a look at the negative out in front here. What this negative means is that it's going to be reflected over the x-axis. Remember, that's the a value is going to be negative. The 2/3 is going to pertain to a vertical, and since it's 2/3, it's actually going to be a vertical shrink. And if you want to say a multiple of 2/3. Okay, the 5 right here, that's acting as our b value. So that means that it's actually going to be a horizontal shrink. And that's going to be a shrink of a multiple of 1/5. The 9 here, since it is adding, we're actually moving it to the left 9 and then the minus 6, which means that we're actually going to be moving it down 6. Okay, so over to the left 9 and then down 6. And then those are all the different types of transformations to that specific type of function. And actually, to tell you the truth, you can't do f of x of f of x, so we're actually just going to change that to g of x. Okay, and to finish this up, find the equation of the reflection over the y-axis. If it's a reflection over the y-axis, that means that x is going to be negative. So anywhere there's an x, you're going to place in a negative x. So I'm going to write this as f of x. It's going to be equal to 5 parentheses a third minus 4 parentheses a second plus 3 parentheses minus 2. What I'm going to do is I'm going to place in a negative x into each spot. Now, to think about what's going to happen here, we're going to have to evaluate this a little bit more. If we have a negative out in front and we have something to the third power or to the first power or any type of odd exponents, that's going to bring out a negative. So for the first one, we're going to get negative 5x to the third. Now with this one, we can't actually take out a negative because that's saying negative times a negative, which is a positive. So we're just going to keep it as minus 4x squared. The next one is going to be minus 3x and then minus 2. So that's going to be equal to our new equation, and we can also use that as y. The next one, we're referring to as y is going to be negative. So we do that whole equation, y is equal to 5x to the third minus 4x to the second plus 3x minus 2. But this time, what we're going to do here is we're going to place a negative out in front of y. But when we solve an equation, we don't have negative y, we have just y. So we're going to write down y is equal to, and then we're going to change everything, right? If we divide everything by -1 or multiply by -1, same thing, each value is going to change, each term. So negative 5x to the third, then that becomes a plus 4x to the second, minus 3x, and then plus 2. Okay, that's going to be our reflection over the x-axis. Now this last one deals with something called parametric equations. We actually don't go into too much detail about this until second semester. It's more along the lines that they just want you to see what it looks like and to kind of manipulate and graph the equation. But this isn't actually going to be on the test. But if you are curious to know, what we're going to do is we're actually just going to make both of these two equations combine into one, just pertain to x's and y's. So I'm going to solve for t. T usually stands for time, by the way. And then plug in whatever t is going to be, which is x minus 2. And then do to the third power minus 4. And this is our typical cubic root function. Typical cube function. So this is moved 2 units to the right, 4 units down, 2 units to the right, 4 units down, and my graph is going off a bit. But what's going to end up happening is you're going to get a graph that kind of looks like this. Okay, from those two parametric equations. Okay, thanks for watching, guys.